So the next presentation is from Markus Fischer, Steering Committee Chair of ITRPV. He's going to give a keynote on overview of high efficiency solar developments. Markus? Markus, you are on mute. Can you unmute yourself?
Okay, so can you hear me?
Yes.
Yeah, so thank you very much for this introduction. So I want to share my screen now. Okay, yeah, great. So can you see my screen? Okay. So, okay, you can see it?
Yes.
Yeah, you asked me. Thank you very much for asking me again here to present ITRPV. So, and I give here the presentation about the 14th edition and current status and some updates and also outlook for the next revision. Okay, so here this will be the outline. First, I give introduction about the ITRPV process, and then the last results, and then I will close with an outlook and summary. Okay, what is ITRPV? How is ITRPV working? So last year or in 2023 we launched the 14th edition, and currently we are about to prepare the 15th edition. And the questionnaire was launched 2 weeks ago, and we invited a lot of contributors and hope that it will become more than 61 for the 14th. So feedback deadline is January 3. And so everybody is encouraged to give his input and to contribute. So we cover with ITRPV the CZPV value chain, starting from silicon over crystallization, wafering, and then cell technology, module, and systems. And the diagrams that are published in the ITRPV publication show median values, and this is what I want to discuss now and give some updates. So the year 2023 is approaching to the end, and what we see is that for sure the learning of PV pricing, PV module pricing continued. And the expectation for the end of the year is that on top of the shipments of 2022, where we had about 300 gigawatt peak shipments at a year-end price of $23 per watt peak, we see here that we will have a shipment of more than 400 gigawatts. And the price is approaching the 10 US dollar cent barrier. So, and this is the expectation for end of the year. So a tremendous growth in shipment. And this means also a tremendous growth in installation. But we see also that there will be a difference between shipment and installation. And what is causing the huge price drop? Yeah, so it's close to half the price at the beginning of this year. So we see that there is a huge capacity in the market, huge capacity for module, cell, wafering, and crystallization was built up. And so we see more than 1 terawatt peak of production capacity. Nevertheless, this shows that PV is on the right track, but the conditions are quite challenging in our days. Okay, so let's come to some details. So we saw in the presentations of the last sessions about here the technologies. So what is clear in the industry and what we found in the ITRPV as well is that current working horse, the P-type material with the PERC technology as leading technology will fast lose market share in the next years, and probably the dominance of N-type material will be even faster than shown here. So we will see with the next edition what is the current status. So what was a key success factor so far for this increase of shipment volume? So this was here a significant contribution given by the different formats. So for in the past, we had for several years, close to 10 years, to work with one format. So this was introduced between 2005 and 2006, at that time by Qcell, so the so-called 6-inch or M0, the 156 times 156. So it lasted until 2016, and now we see a lot of new formats popping up, and this increases by sure the productivity of the cell production lines, and the latest formats also was what was discussed by Trina here. These are the M10R, G12R formats. So there is now, fortunately, a standardization in the market with the widths, with a standard module width of 1,134 millimeters. But we see that in the length there is still some variation possible, and we will see which format will become then the standard of the future. So we see here in the ITRPV the discussion of the different formats, and what is clearly found, M6 and all smaller formats will disappear within this year, and M10 and G12 and maybe also different formats are dominating the market. What we see, this is beneficial for the consumption of polysilicon per watt. So we see here in the ITRPV we report about the polysilicon consumption for different wafer sizes. But the more interesting parameter is then at least silicon consumption per watt. And here we have in the ITRPV published the trend for the PERC cell. And there we see that we are here at at a level of around 2 grams polysilicon per watt for PERC, and the idea and the outlook is that we will go closer here to more efficient use of material. So what we see that there is still a slight difference between the different formats, and M6 and M10 are quite close. G12 is consuming a little bit more. So what we see here, how is this reached? And this is mainly reached by optimizing the processes itself and reducing the wafer thickness. And we see here, this is a prediction of the ITRPV, and we see that current formats are ahead of the ITRPV assumption, and this is more or less the minimum requirement. We see that in TOPCon here, 130 microns are currently standard in the industry, and so this trend will continue, and especially for heterojunction, there are thinner wafers possible. So let's see now here the ITRPV outlook about different technologies, and this was discussed. It is a clear trend. The material shift to N-type is driven by the shift to TOPCon. So N-type TOPCon will be the technology of the future. And the ITRPV predictions here for the year 2023 is that about, so close to 70% of the market will still be PERC, but TOPCon will gain very fast market share. And so we see here for heterojunction and this rear side contact cell concepts, there are also small market shares, but dominating is so far TOPCon and PERC, and TOPCon will be the technology of the next years. So what we see, the big advantage of these technologies here, heterojunction, TOPCon, and PERC, is that they are ready for bifacial, and we learned also that bifacial technology is gaining market share, and now all cells are produced as bifacial cells. So in the ITRPV, we have some, we give some roadmaps for improvement requirements to meet the challenge of getting price reductions and getting cost reduction, especially. And so we always discuss the J0 values. And there we see here for the P-type, so the J0 reduction continued, mainly here driven by the bulk J0, but the shift to N-type is mainly driven due to the better properties of N-type material, and so this excellent properties enable here higher efficiencies. And let's have here also a look on the different contributions to the efficiency from reduced J0 for the different technologies. So one important thing is how can we reduce here the front side J0, and this is mainly linked to optimize silver consumption, and silver consumption currently, I checked here the actual prices. So currently we see that silver is becoming more expensive, and so far it is very important to reduce the silver. So ITRPV assumption is that the silver consumption is about 10 milligrams per watt, and this corresponds to a price of about $0.76 per watt cell. And nevertheless, we see this is the minimum requirement, and in the market we see that the technology is improving very, very fast, and so we are the market is ahead of the ITRPV minimum requirements, and we see for TOPCon here that is slightly consuming, that is considerable, consuming more silver. But we see here big progress. So current values are between 12 and 15 milligrams per watt. And considering this in the world market, so we assume that in the 2023 market, about 11% of annual silver produced will be consumed by PV, but this is still gives room for growth. So a mean how to reduce silver is reducing the finger widths and increasing the number of bus bars. So the 9 and 10 bus bar are about to disappear, especially for the large formats. And here we see that 11 and 12 bus bar, and even here 15 to 18 bus bar are now dominating the market. So this is a mandatory thing to reduce the finger widths. And so to reduce the consumption, and we see as Q cells, so I'm part of Q cells, we see here that there are new technologies in the market, and we developed here together with cell engineering, the so-called LECO technology, laser enhanced contact optimization, and this is a process that enables here by a quite simple and efficient setup, the improvement of the contact formation and a reduction of the resistance, the contact resistance, and enables a significant increase of efficiency between 0.3 and 0.5% absolute. And the LECO technology has been developed by Cell Engineering GmbH since 2016. It's a continuous development process. in close cooperation between CE and Q cells, we improved this technology and put it into mass production readiness. And Q cells acquired CE in 2022. And Q cells is willing to share these benefits of LIGO within the solar industry. And on the other hand, we are also committed to defend this IP to ensure fair and lawful use of LIGO. So you see this technology can be proved in the end product, and who is interested can contact us, can contact me, and so we can find a way to share. So we published this results with our current technology, the Quantum Neo. This is our TOPCon approach. And since we have been using LEGO, we found a significant increase in the efficiency. And so we could ensure here with this simple process good performance increase. So, and this is only here a snapshot of our pilot line performance, and we have similar results in our mass production running in Jinchon. So this brings me here to the cell efficiency trends in the ITRPV for the future. So current standard is for PERC 23.6%. For TOPCon, we see currently here this range even ahead of the ITRPV up to 25% is standard now. So BSQ cell practices. So for heterojunction, we see similar performances. And what we see here, there will be the theoretical limit of single junction cells reached, and tandem is on the horizon. And it will be introduced between 25 and 26 as a commercial product with efficiencies going beyond the 27% performance. So what trends are seen in the module? So we hear that here with module the high cell efficiencies will be also brought to the module, and we reach module efficiencies of above 22%. 22% is standard in current module technology, and we will see that this performance will continue, and TOPCon and heterojunction will show efficiencies in the future of up to 24%. And for higher efficiencies, we will need this tandem technology. So brief outlook about systems for this materials. So main market shares will be determined will be consumed by power plant installations, where we have here also applications for agro PV, for building integrated PV, and for floating PV. Building integrated and here others will stay niches, but rooftop is expected to get a market share of about 30% flat. And so the installation of the future will also be with storage by sure. So, and here warranty outlooks is also clear. So the initial degradation will be reduced. So current 2% will reduce to 1%. And so annual degradation will go below 0.5%. And the warranty life, the life warranty will be here for the product warranty up to 15 years, and for performance warranty up to 35 years are expected. This is what the ITRPV found. Yeah, for the LCOE, so we see big progress thanks to this big improvements. And so in the different markets, we see now also in the US here, that the levelized cost of electricity will go significantly below the $3 per kilowatt hour. This brings me now to the outlook here. So what we see is that the combination of efficiency learning and per piece learning is the base for the future improvement. And over the next year, this will continue. So I summarized here in the ITRPV, it is summarized here the findings regarding efficiency learning and here per piece learning. And so I expect that this year we will have a significant per piece learning. So this we will see. And what we also see is there is still in the market a difference between different regions, and US prices are quite higher than the current market prices. But anyhow, the current measures we define in the ITRPV will contribute to the continued learning, especially regarding the performance. And this brings me now to my last chart. So to give the outlook about where we are in the on the track towards completely carbon-free industry. And if we will go here to 400 gigawatt in 2023, so we will be on track for this market curve that we show here. And the expectation is that we will have so more than 1 terawatt market in 2030. So this is ahead of the predictions of the IEA expectations, and so also for their net zero expectations, they think that 26% of PV share will be in 2050, but we expect that here's a brighter scenario of about 69% by PV can be covered and can be reached. So key is to continue here with the cost learning, with the per piece learning, and then the prices will stay at a reasonable value, and the ITRPV will also for future provide guidance to handle today's and future challenges. And thank you for your attention, and please contribute to the 15th edition, and I invite you to be part of the ITRPV community. Thank you very much, and maybe there's time for some questions.
Thanks a lot, Markus. Actually, it was a really great, nice keynote, and very great outlook. So unfortunately, we don't have time for questions. So I would like to go ahead, but before I move on to the next presentation, I would like to request also.
Okay.
On
so then,
Markus,
thank you very much. Bye.
Thank you. So please. Bye. Support ITRPV. It's a great initiative. We all learn a lot from their roadmap. So whoever is the decision maker here, we always really like to support ITRPV. Thanks a lot, Markus.
Thank you very much. Bye. Take care.